Ahoy, science explorers, the floating mystery. Have you ever stood at the edge of a harbour watching massive ships glide through the water? It's incredible, isn't it? These gigantic vessels loaded with heavy cargo somehow manage to stay afloat. How do they do it? It feels like magic, but it's all thanks to science. Get ready to dive into the fascinating world of buoyancy and discover the secrets behind floating ships. We're about to embark on a journey to uncover the scientific principles that keep these colossal structures from sinking. From the legendary Archimedes to the ingenious design of ship hulls, we'll explore the forces at play that allow ships to conquer the seas. Fasten your life vests, science explorers, as we set sail for a voyage into the world of buoyancy. Buoyancy? It's like magic, but science. Imagine you're holding a cupcake with colourful sprinkles. Now picture gently placing that cupcake in a bowl of water. What happens? Does it sink to the bottom? No way! The cupcake floats. That's buoyancy in action. Buoyancy is an upward force exerted by a fluid that opposes the weight of an immersed object. In simpler words, it's the force that pushes things up in water. When an object is placed in water, it pushes some of the water out of the way. This is called displacement. The water pushes back on the object with an upward force which we call buoyancy. If the buoyant force is greater than the object's weight, the object floats. If the object is heavier than the buoyant force, it sinks. Archimedes' Eureka moment, water displacement. Let's travel back in time to ancient Greece and meet a brilliant scientist named Archimedes. Legend has it that Archimedes was taking a bath when he made a groundbreaking discovery about buoyancy. He realized that the amount of water that overflowed from his bathtub when he got in was equal to the volume of his body that was submerged. This realization sparked a legendary Eureka moment. Archimedes' principle states that the buoyant force acting on an object submerged in a fluid is equal to the weight of the fluid displaced by the object. This principle is key to understanding how ships, despite their massive size and weight, are able to float. The shape of a ship's hull is designed to displace a large amount of water, generating enough buoyant force to counteract its weight. Section 4. Hull design, the shape of flotation. The secret to a ship's impressive buoyancy lies largely in its ingenious hull design. The hull, the main body of the ship, is carefully shaped to maximize the amount of water it displaces. Think of it like this. A flat piece of steel will sink because it doesn't displace much water. But if we shape that same piece of steel into a hollow bowl, it can displace a much larger volume of water, allowing it to float. Shipbuilders utilize complex mathematical calculations and years of experience to design hulls that are not only buoyant, but also stable and hydrodynamic. Factors like the ship's purpose, cargo, passenger, military, the type of water it will navigate, calm seas, rough oceans, and the weight it needs to carry all influence the final hull shape. Section 5. Density decoded saltwater secrets. Have you ever noticed that it's easier to float in the ocean than in a swimming pool? That's because salt water is denser than fresh water. Density plays a crucial role in buoyancy. Objects float better in denser fluids because the fluid itself provides more upward force. Let's conduct a simple experiment to illustrate this. Fill 2 glasses, one with fresh water and the other with salt water. Now drop a grape into each glass. Observe what happens. You'll notice that the grape sinks in the fresh water but floats in the salt water. This is because the denser salt water provides a greater buoyant force, allowing the grape to stay afloat. Section 6. Ships afloat, it all comes together. From cupcake buoyancy to Archimedes' bathtub revelation, we've journeyed through the fascinating science of flotation. We've learned that buoyancy is an upward force exerted by fluids, counteracting the weight of objects. Archimedes' principle taught us that the weight of the fluid displaced by an object determines the buoyant force acting upon it. We discovered that a ship's hull is expertly designed to maximize water displacement, generating sufficient buoyant force to keep it afloat. Remember those massive cargo ships we marveled at? Their ability to float is a testament to the power of science and engineering. By understanding and harnessing the principles of buoyancy, density, and fluid dynamics, we can design vessels that navigate the vast oceans, connecting continents and cultures. So, the next time you see a ship gracefully gliding through the water, take a moment to appreciate the science that makes it all possible.